All right, let's take a look at the 2.4 practice now for deductive reasoning. It says, let's just start at the beginning and work through a few of these. So, if possible, use the law of detachment to make a conclusion. If it's not possible to make a conclusion, tell why. So, just like our example in our notes, for the law of detachment, we're going to do this same thing again. So, if a triangle is a right triangle, then the triangle has one 90-degree angle. Triangle ABC is a right triangle. So I like to find my P and Q first. There's our P. If P, a triangle, is a right triangle, then Q, the triangle has one 90-degree angle. We've had a lot of practice with that now, so I'm sure you guys are getting tired of that. Triangle ABC is a right triangle. You can see that matches what our P was saying, right? It says P is true. That's what we're looking for on this law of detachment, is P is true. I'm going to write that out. P is true. So we can say Q is true. And Q says the triangle has one 90-degree angle. So I'm going to write that over here. Triangle ABC has one 90-degree angle. Not too bad. All right, let's look at number 2. If a parallelogram has 4 congruent sides, then the parallelogram is a rhombus. The parallelogram has 4 congruent sides. So let's underline our P. A parallelogram has 4 congruent sides. Then a parallelogram is a rhombus. So Q is the parallelogram is a rhombus. And if you're not remembering what that word rhombus means, I think some of our classes we went over it, but a rhombus kind of looks like a kite or a diamond. Well, that's a really bad one, but you get the idea. It's kind of like a slanted square, whatever you want to call it. That's a rhombus. So now back to this example. So this one's telling us the parallelogram has 4 congruent sides. So we need to ask ourselves, is this saying that P is true? Because that's what we need for law of detachment. Our P up here says a parallelogram has 4 congruent sides. This one says a parallelogram has 4 congruent sides. So we're saying P is true, so now we can say Q is true. So the parallelogram is a rhombus. Okay, let's look at number 3, and then I'll let you guys work through 4 through 6, but we'll do a few of the other examples too. So this one says, if x is greater than 7, then the absolute value of x is greater than 7. So we have if P, then Q. If x is greater than 7, then the absolute value of x is greater than 7, and this is telling us x is less than 7. But this does not match what our P was, does it? That's not P. So we definitely cannot use that for our law of detachment, right? If you have your notes out next to you, which would probably be helpful, we know that it has to say P is true. This one does not say that P is true. So this one is not possible to make a conclusion. So let's write not possible. And my reason why was that it's not P. All right, let's look down here now at the law of syllogism. We'll go over that too. If possible, use the law of syllogism to make a conclusion. If it's not possible to make a conclusion, tell why. So number 7 says, to take pre-calculus, you must first take algebra 2. The next one says, to take algebra 2, you must first take algebra 1. Now, this one might look a little bit confusing because we're used to using if and then, right? So this one's written a bit different, but this is still our if-then statement here. One way of thinking about this is your if would be around here, and your then would be here. So if we were to put in some filler words to make it a nice sentence, it'd be, if you want to take pre-calculus, then you must first take algebra 2. Same thing for this bottom one. So don't let that one freak you out because there's no if and then. Same thing we've been working on. We still have our P and our Q. So this next one, we also have P and Q. But let's see, to take pre-calculus, you must first take algebra 2. Then the next one says, to take algebra 2, which we can see is the same thing that we circled for Q, right? So let's label these P, Q. This one's also Q, right? You must first take algebra 1. That's something completely new, right? So let's, like I did in the notes, I'm gonna give it some squigglies, and that one will be our R. And I'm just doing the squiggles so you can see it's something new and different, right? So if P then Q, and if Q then R, you can kind of see those symbols that we need, right? So this matches our law of syllogism in our notes, right? So now we can say if P then R, which would be if you want to take pre-calculus, or you could have just said to take pre-calculus, but I'm going to write it the way we know with our if. So if you want to take pre-calculus, you must first take algebra 1, right? First, take algebra 1. All right, let's look at 8. If a tree has ragged bark, then the tree is unhealthy. If a tree has ragged bark, then the tree might be a birch tree. So we have our if P, if a tree has ragged bark, then Q. So then the tree is unhealthy is our Q. Now we have if a tree has ragged bark again. And now let's look. Do we already have that circled or underlined? Yeah, we do right here, right? If a tree has ragged bark, that's the same exact thing right here. So that's going to underline so we can see that's the same thing. They're both P, right? And then it says, then the tree might not be a birch tree. That's something completely new that we haven't done anything with yet. So let's give it the name R. Now, law of syllogism, we need if P then Q, and if Q then R. But on this one, you can see we have this top part, P then Q, but then we have P then, oh, that's not a P. Then we have P, if P then R. This is not the law of syllogism, right? This one is. So we're not going to be able to do anything with this one here. So not possible to make a conclusion. I'm going to write no conclusion. And you have to explain why this isn't the law of syllogism. Kind of like I just did out loud. You can use your symbols. You can write a sentence like we did it on our notes. Either way. Let's go on to these ones down here now. Let's do number 13. So these ones say you can use the law of detachment and the law of syllogism to make a conclusion. So we're going to have to, I'm really going to mark these up so you can see what's going on in these. So let's look at what we have for this first one, number 13. It says, If you live in the Fairbanks, then you live in Alaska. And by now, you guys know I like to mark up my stuff, so I'm going to make my P underlined. You live in the Fairbanks. Then Q, I'm going to put you live in Alaska. There's our P and Q. Now it says if you live in Alaska, which is the same as right here, right? So I'm going to circle again so I can see that that's Q. Then you live in the largest state in the United States. That's something new, right? Let's give it a bunch of squiggles here. That's going to be our R. Now, it's not done yet. It also has this, Alan lives in the Fairbanks. Is that like anything we've underlined, circled, or squiggled under yet? You can see P was you live in the Fairbanks. This is saying Alan lives in the Fairbanks. So that's telling us P is true, right? P is true. Isn't that law of detachment? We can do something with that, right? If P is true, we're allowed to say Q is true. We also know from law of syllogism, if we have if P then Q, and if Q then R, then we can say if P then R, right? So we have Q is true. We can say Alan lives in Alaska. Because of law of detachment. I'll write that out for you. Detachment. And you also can say if P then R, right? Because our law of syllogism holds up here. So if you live in the Fairbanks, then you live in the largest state in the United States. All right, I'm going to leave the last ones for you to look at through there. I gave you a decent amount of the work, and we worked through it. Hopefully they made sense. So go ahead and email me if you have any questions. And make sure you don't lose this. That way you're able to turn it in. I'll write my email up here. Email A-L, my last name, Grimes, at lsc.k12.in.us. So feel free to email me with any questions, and don't forget about your Canvas homework too.